In order to understand AI and ethics, we have to understand the machine learning paradigm. So everything we call nowadays AI is actually machine learning. I mean, that doesn't mean that all AI is machine learning. There are other ways of rules-based, expert system, and so forth. But everything that works nowadays, when you read AI in the newspaper nowadays, that is machine learning. So the idea that the machine learns itself from data. And that was so revolutionary because it turned the knowledge paradigm on its head. And we have to understand what it did there in order to understand the risks and the ethical risks that AI is bringing. So how is the traditional knowledge paradigm actually working? Well, traditionally, I have also data. I start with data. And I put it in something that computes, a computer. And so I have observations. I can look around in the world, or I have numbers, 2, 1, 2, 3. And then I manipulate them according to some kind of recipe. Every time somebody says algorithm, just replace it with the word recipe, like a step-by-step procedure to do something. That's much easier to understand. For all practical purposes for us, you can use them interchangeably. So, for example, you have somebody learning a new trade, a profession. You look around, you get familiar with the machine, you process a lot of data, and then a master teaches you how to operate that, and that produces a result. Now you know how to operate the machine, or you calculate. That's how we teach kids in our school. Or you learn how to drive a car. You first of all have to spend a lot of time processing a lot of data, visual data and so forth, and reaction data, and then you process all of that. Somebody teaches you to drive a car, and you find out the way of doing things, the recipe, and once you have that, you have the result. The goal output is you have the knowledge of driving a car. So what did machine learning do with that? It turned it upside down. It really turned a big part of it upside down. It gives you the data and the result, and it computes the best way of doing things. So I'm telling you where you are and where you want to go, and it tells me the best way of getting there. You could also get to 12 like that. Don't believe me? Yeah, 2 and 1 is 3, and square is 9, plus 3 is also 12. Now, what's the best way of getting to 12? Well, we have to talk about that. Has to do, well, actually with the details of these two. All you can manipulate actually is these two inputs. So you have data, and it depends on the details of it and where you want to go, and then you can find out the best way of doing things. And that's what we do in industry as well. For example, for the last 7 years, was this chief digital strategist of one of the world's biggest copper mines out of everything, and that's basically what we do there, right? So you have you have stones and you have machines, and you say what you want to produce. In that case is copper, and you want to produce it sustainably and so forth, and then you ask the machine what's the best way of achieving that. Or last month, I've been consulting with a central bank. And yes, you have consumers and transactions and economic data, and the goal is to assure the stability of the currency. And then you ask the machine how you could be doing that. That's the idea here of machine learning. And you have these two things that you can manipulate, the data and the goal, the reward function, and then you have here the output is an algorithm. That's why Pedro Dominguez calls it the master algorithm. It's the algorithm to compute the best algorithm. That's hence the master algorithm. It computes the best way of doing things. And ethics actually affects all of these different components of the machine learning paradigm, of AI's machine learning paradigm. There are the 3 most common schools in ethics, in the theory of ethics, are virtue ethics, deontology, and consequentialism or utilitarianism. And they actually fit very well, when I understood that, fit very well to these different concepts. So virtue ethics is kind of like you being ethical. You are ethical, and that's what you are. So your data, you can give the data matters. If you give the machine ethical data, it will learn to be ethical, because if you give it unethical data, it will learn to be racist and sexist depending on the data that you give it. So that is a first very important thing, is the being of being ethical. Then the deontology is the ethical intentions. So that's the goal orientation that you give it, the reward function that you give your machine learning. It's a very Kantian philosophy from Immanuel Kant. The categorical imperative means always act as if your action could become general law. So you have an intention behind, and once you have good intentions, yes, then you act ethically according to deontology. Now, as they say, the way to hell is paved with good intentions. That's then when the consequentialism people come in and the utilitarianism. They say, no, it doesn't really matter what your intentions are. Even if you have good intentions, but it has a bad result, then this would be unethical. What's the consequence of your actions? Who you are and what you would like doesn't matter. It matters only the outcome. So these are the three schools, and what we will do now in the following, we will go around that and look how these different three schools of ethics relate to the machine learning paradigm.